All right, guys, today we're going to go ahead and go through Unit 1 review. Remember, we're just going to follow the directions and do what it tells me to do. All right, 1 through 2, 1 and 2. We're going to go ahead and underline the coefficients, put a box around the variables, and circle the exponents. Remember, a coefficient is a number in front of a variable, so it has to have that letter attached to it. If there's no letter, it's not a coefficient. It's called a constant. It's by himself. He doesn't change. So our coefficients are, I'm going to switch my color a little bit, 5, 8, and 3. So we're going to underline 5, 8, and 3. And I know the 5 didn't get the underline the best. I was going to try and fix it. It's a little hard on a computer screen. Then we're going to put a box around the variables. So any letter gets a box. Just the letter. As best as you can. Again, you have a piece of paper and a pencil. It's a little bit easier than me doing this on my computer screen. And then you're going to circle any exponents. And remember, an exponent is the small fonts and a superscript. It's up above. Now, again, 21 doesn't have anything on him, but he's not a coefficient, he's not a variable, and he's definitely not an exponent. So he's just left out. Oh, I hit the side of my screen again. I did that earlier. Oops. All right. So we're going to go ahead and underline our coefficients in number 2. So that gives me an 8 and a 3. We're going to put a box around the variables, so M, P, and W. And we're going to circle our exponents of 2. Next, we're going to go ahead and solve for our literal equation for whatever variable. This is where we want our little highlighter. And we're going to highlight the letter we're looking for. And in this first one, we're going to look for W. So right now, my P and my R are being added to my 2 and my W. Well, I want to get rid of them. So what I'm going to do is I'm going to go ahead and subtract it since they're being added, and he's not helping me out there by being added. So minus PR to both sides. That causes these to cancel on the left side. So I'm left with 2W is equal to capital B minus PR. And then we're going to go ahead, get our highlighter out. Again, identify my letter. We're still looking for W. Now, if you notice, W is being multiplied. So how do you undo multiplication? You subtract. Right. Good call. What I do to one side, I do to the other. Those cancel out, and I'm only left with W. And so W is equal to P minus BR all over 2. And that's my final answer. Sorry, I wrote into the next problem. Oops. Okay, let's get our highlighter again. We're going to look for R. R is right there at the tail end of that equation. Right now, everything's being multiplied, so the best way to undo multiplication is division. And I do it to both sides, and I want every single piece gone. So that causes that all to cancel out. So I'm left with C over 2 pi is equal to R. And again, we know that W on one side or R on the other or whatever is still an equal statement, even though I have them maybe not on the same side always. Sometimes I have them on the left, sometimes I have them on the right. They're still an equivalence, which means that nothing changes. You're still you, even if you have your PJs on versus a dress. It doesn't matter. All you're doing is changing the way it looks. All right, number 5. Go back to getting our highlighter. We're going to go ahead and solve for y. Y is up top in my numerator. Again, I say the word numerator because we have a fraction. Oh no, scary fraction. It'll be okay. We undo fractions with multiplication. Do it to both sides. The a's cancel out. I'm left with xy is equal to a times z. Let's go back. Let's get our highlighter out. All right, I'm looking for y. Y is hanging out with the x. I need to undo that hangout. Go away. We don't want to hang out with you today. I just want to hang out with y. Y is all by himself now, and he's equal to a times z divided by x. All right, solve each of the following equations. So remember, we're going to do our order of operations in reverse. We're going to go backwards. Typically, we start with our addition or subtraction, but if you notice, my subtraction currently is being divided. And since that division happens to every single piece, I have to deal with him first. So I'm going to start by multiplying both sides by 4. So I have y minus 3 is equal to negative 64. All right, now I got to undo that subtraction, so I'm going to add 3 to both sides. And even though my 64 is negative, remember, he's super negative, so when I add, he ends up becoming a little bit smaller and is negative 61. Number 7, oof, got lots of stuff going on here. So we're going to undo any addition or subtraction first. So if I take a look, I'm going to get my highlighter back up for a second. If you notice, the b is being added, technically is being subtracted with the rest of this problem. So he's what I'm going to go after first. So I'm going to add b to both sides. No, I'm not. Dumb moment. Back up, rewind, hit the pause button. For some reason, ignore this here set of parentheses. Parentheses always have to be simplified first. I apparently overlooked that for some reason. Couldn't tell you why. So, hi.
I'm interested in that.
Okay. All right, so we're gonna go ahead and multiply that 4 through. So 3 times 4 gives me, ooh, I didn't fix my eraser size either. Ah. So negative b minus 12b minus 20, because again, 4 goes to both terms, equals negative 59. Now we're going to go ahead and combine our like terms. So negative b minus 12, so I have negative 1 and then 12 more, which gives me 13. Next, I'm going to undo that subtraction by using my addition rules. So negative 13b is equal to negative 39. And my last step is I'm going to divide by negative 13. Negative divided by negative will give me positive, and that is a 3. All right, I'm going to pause. I'll come back to you guys in a moment.